My name is Greg Friedrich, and I've been building cars my whole life. I have a shop called Gizmos. Our cars are hand-built. Our race cars win car shows, and our show cars win races. Our cars are as beautiful as they are functional. I had a client that was a good friend, and we shared the same passion and dream. We had a partnership on a land speed car. Our goal was to do 200 miles per hour. We got close, but then it all came to an end. It felt like unfinished business. Sometimes you just have to start over.
All right, go for it. Yeah, so we're working on the tube chassis here for our land speed car. This is the front section. It starts with the main cross member, which is tied into our main hoop. That's probably the most important part of the chassis. It's what's going to save the driver if there was an error to occur. And I'm pretty much sitting in the driver's seat. We're using 1 5/8 chromoly by 120 wall thickness. And we've kind of just begun. This isn't very far in the process, so these are the main frame rails right here. They run parallel to each other. A lot of this is very important that it's symmetrical and evenly spaced, and that's all based off of our center line we have here, which is just a nylon string, but we recheck that for accuracy very often. Once we've got the main frame rails and the main cross member, everything else is built off of that. And so we'll extend out. Right here we're installing the X, which is a reinforcement. And with these, it's super critical to have a nice, clean, tight fit. So when they're welded, they seat with each other really solid. And that's what's going to create the rigidity you need for the safety. Otherwise, you could just use a normal chassis on a car. But that's no fun. I've got one section of the X already cut out, found the angles. And so what I did is just make 2 of those, but then the second one I've cut in half, which is kind of intimidating because you put in all that work just to cut it in half. And so we got this little jig here that we've made that helps ensure that they're going to run in line with each other, because you don't want it to be crooked. You know, it goes back to the symmetry part where you want everything the same on each side, because that helps build strength. Yeah, this tube chassis, it's a higher quality steel. It's really rigid, but there's a lot of flexibility. And believe it or not, race cars, their chassis flex a lot. And with the chromoly, you can get what's called springback, or it's like a memory. It'll maintain its shape after you've kind of flexed it. It'll kind of spring back. That's where the saying comes from. And so a normal car really wouldn't do that. Once you get it so far, that's the position it's in, and that will throw everything off. You're going to crash a car that's got a twisted frame like that. It has the flexibility and rigidity at the same time, which a lot of other metals don't have, so that when this car leaves the line, you know, at RPM and it launches, it's going to flex. If you've ever seen like videos of cars, they'll kind of, when they do a wheelie, one side will be a little higher. That's part of the launch process. Some do it a little better than others, and it's all into the geometry of how you assemble everything and your suspension, and one thing plays into another, but it's all based off of your chassis or your tube frame. This is what we're going to build off of. And so the main frame rail and this X and this main hoop and this main cross member are going to be the strongest, and that's where we're using 120 wall, so it has super rigidity. Like some of the other aspects, we'll probably use 095, which is a lighter just because it's thinner, but it's all the same strength, and there's not a lot of flexing that'll go on to the cab area versus the main frame rail. What I'm doing here is just installing the X or cross. It's just a reinforcement for the main frame rails that run the length of the car. It's pretty tricky, being that there's some hard angles here, not just 45 or 90. What I've done is I've compared both my tubes together. I do have one that's fairly shorter than the other, so I've marked that reference line from that one onto this one, and that's just by holding this one up to that one, seeing where that one's line is, and copying that. And so there's a lot of copying, I guess you could say, in what we're going on here. And so what I'm doing now is I'm going to notch this down to match that one. And here's the Bailey Industries tube notcher that we've got. It's a really, really nice piece of equipment. It's got all the axes, so you can, like right now I've got it turned to 43 degrees about. And with this cam, it locks into place and I can repeat this cut for days. Double check my alignments on here. Pretty simple with an angle finder here. I've just got a little bit of correction to make. And this part can get a little tedious because you're kind of splitting hairs, but you want to be able to repeat that same cut every time. So the tolerances are next to none on these small aspects, but that's what makes a really good result in the end, and so that's what we're looking for. Put on my eye protection. And then I just keep a hand here because I like to make sure this doesn't change. All right, lots of deburring going on. You don't want any little pieces of metal in between this one and the tube you're fitting it to, because that obviously makes for a bad fit. And then this tube chassis is going to have to be TIG welded together. That's what helps the rigidity with the chromoly. You wouldn't want to MIG this together. And so when you're TIGging, you have to be really clean. The metal has to be clean, the area has to be clean, and it just looks better. All right.
Because he's over here working, you know.
Somebody got it. Somebody's got to build this fucking car.
All right. So, just by looking at it, it looks pretty good. Everything seems to be fairly matched up to my references. I do have some gapping here that I want to take care of, but that's to be expected. But essentially, this is what you're working towards. Consistent referencing helps a lot. If you have to move a line a little, that's going to throw a lot off. So you really want to do it right the first time. That's why with some of this, especially with this X, with this scenario here, we kind of walk them in slowly, lead into it, not just jump head first. Yeah, so I love that notcher. I could repeat that same cut over and over again. Makes life a lot easier. So you can get a lot more done in one day.
And that'll help with that crap. I kind of lost my place there.